Now we're looking at finding critical values. The critical values are the values that we would have to get from our test in order to say that we're going to reject the null hypothesis and we think there's evidence that the alternative hypothesis is true. So if we're testing at a 5% significance level and we've got some distribution, the 5% significance level would mean we're going to look for the most extreme 5% of results. So if the null hypothesis is true, the chance of getting a result in the critical region has to be 5% or less. And if it's in the 95%, the other 95%, we're going to call that the acceptance region. And we're going to say there's not enough evidence to reject the null hypothesis. So let's look at a question. A random variable x is binomially distributed. N is 40. And the null hypothesis, H0, is that P, the probability, is 0.3. The alternative hypothesis, H1, is that P is actually greater than 0.3. Find the critical region for a test at the 5% significance level. I'm going to use a calculator to find this. So we're going to look for the most extreme 5% of results if P is 0.3. So I'm just going to grab the calculator. We're in binomial distribution, and we're going to look at the cumulative binomial CD for a variable. So x. Now we can put in any number here, and we're going to try and find the most extreme 5%. If we do 0.3 times 40, that's what we'd expect to get. So 30% of 40, we'd expect there to be 12 on average. So let's go higher. Let's try a 15 out of 40, with the probability being 0.3. So what's the chance of us getting a 15 or less? That is 88%. So we need to go higher to find the most extreme 5%. If we try 16, that takes us to 93%. Still not the most extreme 5%. So let's go 17. And that takes us into our most extreme 5%. So the probability of getting 17 or less is 96.8%. So the probability of x being less than or equal to 17 was 17, wasn't it? 96.8%. Yep, 17, 96.8%. So what is the critical region? We're going to take anything above 17 and say the chance of that is less than 5%. It's going to be just, 3.2%. So the probability of getting a result that's 18 or greater is 3.2%. We're going to say that that is our critical region. So it's 18, anything from 18 is 40. So 18, anything from 18 to 40 is going to be our critical region. Anything between 18 and 40 would be in the most extreme 5% if the null hypothesis H0 is true. And what is the actual significance level? We've already written that down. It's actually 3.2%. There's actually a 3.2% chance of getting something between 18 to 40. Okay, a question for you to try. See if you can give that a go. So a random variable x has the distribution binomial, n is 50, given that the null hypothesis says probability 0.25. The alternative hypothesis is it's less than 0.25. Find the critical region for the test at the 1% significance level. So this time we're looking for the most extreme 1%. So let's just use the calculator and see what we get. So a quarter of 50 is 12.5. So let's go lower. I'll start with a 9. There are 50 and the probability 0.25. So 9 is 16%. We want to go lower. 8, 9%. 7 is 4%. 6 is still over 1%. 5 takes us below 1%. So the probability of 5 or less is, what's that as a percentage? Times it by 100, 0.7%. So the probability that x is less than or equal to 5 is 0.705%. So the critical region is anything from 1 to 5. The chance of getting anything from 1 to 5 is just 0.705% if the probability is actually 0.25, if our H0, our null hypothesis, is true. And the actual significance level is 0.705%. Here we've got another question. This time the null hypothesis is 0.3, but the alternative hypothesis is just that the probability is not 0.3. So it's not specifying whether it should be higher or lower. This makes it a two-tailed test. A two-tailed test. So we're going to split our significance level. If we've got a distribution that looks like that, we're going to split our critical region, our significance level. So we're going to have 2.5% on each side. So in total, the critical region is 5%, but we're splitting it. So the most extreme 2.5% above and the most extreme 2.5% below. So we're just going to do the same thing. We're going to plug it into the calculator and try and find the most extreme 2.5% on both sides. So binomial cumulative, and x, we can pick anything. Let's start with the one below. I'll try 8. N is 40 and P is 0.3. So that's 11%. We want 2.5, so let's go lower. 5%, lower again. And there we have it. So 2.38%. So that's 6 or less. 2.38%. And we also need another critical region. So we're going to have anything from 1 to 6, but also we want the other side. Let's try 15, 88%. 16 is 93. 17 is not 2.5%. Let's go higher again. 18 is. So that's the probability of 18 or less. So the probability of 19 or more, x is greater than or equal to 19, is going to be 1 minus our answer. And I'll times it by 100. So 1.48%. So the critical region is anything from 1 to 6 and anything from 19 to 40. One question for you to try. See if you can give it a go. So again, we're going to have a two-tailed test. So we're going to split it up to 2.5% at the bottom, 2.5% at the top. So the most extreme 2.5% of results on both extremes. And let's just use the calculator to work out where that most extreme 2.5% is. So I'll start with, let's try a 7. So 7 is 4.5%. 6 takes us below, so 1.94%. So the probability that x is less than or equal to 6 is 1.94%. So that's our most extreme on the lower end. For the upper end, so 17 is 94%. 18 isn't quite, it's not quite 2.5%. So let's go to 19, which is, so the probability of 19 or less is that. So the probability of 20 or more is 1 minus the answer, which is 1.39%. So the critical region is anything from 1 to 6 and anything from 20 to 50.